Today we start our last big topic of the course, and it is called hypothesis tests. We're going to break this introduction into two sections. So we're just going to get started with the idea and the first couple parts to it, and then build the whole test next lesson. A hypothesis test is a mathematical way of testing a claim that someone makes. You're watching advertisements and people make claims all the time about their products. And this is a way that you can actually statistically measure if those claims are accurate. So let's jump in with an example. Let's say that I make the claim that the mean height of a college student is 5 feet 4 inches. Okay. I made that claim. There's no evidence to support or refute that. And you come in and you say, I'd actually like to test that. I'm not sure if that's true. So what I'm saying in my claim is that if the heights are normally distributed, that the mean here in the middle is 5 feet 4 inches. Okay, that's what I'm claiming. That may or may not be true. So when you're going to do a hypothesis test, what you do is you come in and say, okay, I'm going to pull a sample. And let's say, let me draw this picture again. Here's your population. This is all your college students. You're going to take a sample. You're going to pick an appropriate sampling method. And we're going to call that X bar 1. So you're going to figure out the mean height of your sample, and that's going to be X bar 1. Let's say, for sake of argument, that X bar 1 turns out to be 6 feet, whoops, that's inches, 6 feet 1 inch, 1 inch. Okay, so you take your sample, it's a fair sample, you calculate the mean, and your mean height is 6'1". Well, if we look at what I claimed, 5 feet 4 inches, 6'1" is quite a bit up here. Yeah. I mean, I don't know what the standard deviation is, but I mean, that's quite a fair way away. So if that happened, I would say, hey, in your scenario, if we assume that your claim is true, then it should be very unlikely that I get a population sample of 6 feet 1 inch. Yeah, I mean, that's what these normal curves do. Remember in chapter 5, we were taking a value like 6'1", assuming that this is the mean, and we are calculating these percentages, right? And you know from the pictures that you were drawing that if you ran this through your normal distribution on your calculator, you would get a pretty small percentage. Like it would be probably like 0.01 or something like that. The chances that you pull a sample like that are very small. And that's that area under the curve there. Okay, that's the probability that what the sample that you just pulled would happen again. Okay. And for purposes of a hypothesis test, we're going to call this value P. Okay. So P is the probability. Whoops. It's the probability of pulling a similar sample again, or one that's more extreme. Because P is not just this value at 6'1", it's all the options above that. So P is the probability that I get an average of 6'1" again, or anything worse than that. Okay, so in this situation, I would come back and I'd say, I don't actually believe your claim because the chances that I pull a sample of 6'1" with 5'4" being my average are very small. Okay, that's the idea of a hypothesis test. Now, let's say I had pulled a sample and my sample height was 5 feet 5 inches. Well, then I'd say, your claim might be right because my sample is actually lining up with what you claimed to be true. Okay, now how do we decide? I mean, obviously, if we've got 6'1", that's an extreme value. You know, if you pull 5 feet 5 inches, That's a pretty close value. So those are obvious that one of them supports the claim and one of them doesn't. But what if you get a value in the middle? You know, say you had 5 feet 7 inches. Who's to say if that is an extreme value or a typical value? And the answer is that in a hypothesis test, we set a threshold. We say, hey, I'm going to create a line right here, and I'm going to say anything from that line up into the tail. And if I'm doing high averages, but we could be doing the same thing down here for low averages. But like from that line up or that line down, these are going to be considered our values that are too extreme. This is the value that we call alpha in a hypothesis test. It's a threshold for our, I'm going to call them unusual values. It's the line where we say, hey, this p-value is too small, or this p-value is okay. It's our dividing marker. And that threshold can change depending on what you're doing and who's monitoring it, et cetera, et cetera. Okay, but that's just, I'm kind of just trying to set up the notation here first. Okay, so what we're going to do when we do a hypothesis test is somebody's going to make a claim, and we need to write some mathematical statements to talk about what the claim is and then what the claim isn't. So we're trying to cover all of our bases. Like if I say my average height is 5 feet 4 inches, then what the claim isn't is everything else. So we're setting up a mathematical statement that mirrors the claim and then also its complement. So we're going to practice doing that really quickly to make sure everybody's cool with that. All right, so here's one claim. The mean sleep time of a cat is at least 10 hours per day. All right, so we're talking about the mean. So my variable is going to be a population mean because these claims are all about the population. We will then sample and take a sample mean to compare, but the claim itself is always about the population. So the population mean sleep time of a cat is at least, so at least is bigger than or equal to 10 hours per day. So this is what the claim is. Now, I also want to be clear about what the claim is not. And so I want to write the complement of this claim. Sometimes I think it helps to draw a picture. You do not have to draw a picture, but I want to do that so that you can see. So here's 10. When something is bigger than 10, we shade to the right. Bigger is to the right, less than is to the left. So I'm going to shade this to the right. Those are all my numbers on the number line that are bigger than 10, but this line under it means or equal to. So that means I'm going to include 10. So I'm going to draw a dot and I'm going to fill it in. So that tells me it's 10 or anything above that. Now, what is the claim not saying? The complement is everything else. So it's everything less than 10. So the complement is going to be less than 10. Mu is less than 10. Now, the reason it doesn't have a line under it is because the 10 was taken up in the claim. That was the or equal to. So now we're strictly less than. So as you can see, what happens with the claim and the opposite and the counterclaim is one arrow goes to the right and one will always go to the left. One will have the line under it and one will not. That's the pattern that will always happen. Okay. So let's look at another example. The mean exercise time of American is less than 40 minutes per day. So again, we're talking about the mean, population mean is less than. So now I'm arrows pointing towards the mean, less than to the left, 40 minutes per day. Okay, draw a picture again real quickly. Here's 40. I'm less than. That's to the left, but I'm not including 40 this time because there's not a line under the inequality. So it looks like that. So now my counterclaim is going to be the 40 and everything above. That's the complement. So I'm going to say the mean is greater than or equal to 40. So this top one's the claim. The second one's the complement. See how those, so at the end of the day, the reason the picture is helpful is at the end of the day, everything needs to be colored in white or purple. If you missed a part, then you missed, one of them's wrong. See how this one up here, everything's colored, the 10, the right, and the left in either white or purple. There's no gaps. Okay, let's do one more. The population proportion of people who believe in UFOs is 54%. Now, again, look, this we've seen this before. What's that mean? It means that it's binomial. Also, tip off is I've got a percentage, and then I ask myself the question, do you believe in UFOs? Yes, no, it's binomial. So now I'm not talking about population mean, I'm talking about a population proportion. So I'm going to use the value P because that's what you use for population proportion. And the people who believe in UFOs is 54. Now, this is not greater than or less than, it's actually exactly 54. So this is going to be equals 0.54. So how do we draw this picture? Well, here's 0.54, and I just have a dot right there. That's it. So where's the complement? It's everything above and everything below. The only thing that's not in the complement is 0.54. So the way we write that is not equal to 0.54, everything else. Okay, now what you're going to be practicing writing some of these claims and their complements. One of the things that's hard for people usually with this is translating these words into the mathematical symbols. So this whole less than into that, and the at least into that. So I've made a chart of typical words that show up and the symbols that go with them. So if you want to take a screenshot of this, or if you want to pause and write them down, that's fine too. So the way this works is these words, anytime you have more than, greater than, or above, then you're going to take, now I just use mu just because that's a common one, but that could be P, it could be standard deviation, whatever we're talking about. Okay. So that letter can change depending on what the topic of the problem is. But the point of the chart is that your sign is going to open to the left for those guys. Okay. Anytime I say at least, greater than or equal, or not less than, you're going to open to the left, but you're going to have a line under it. Okay. Anytime I say is, equal, or exactly, you're going to put equals. Anytime I put less than, fewer than, or below, your arrow is going to be to the left. Anytime I say less than or equal to, at most, or not more than, it's to the left with a line under it. And anytime I say not equal, different, not, or changed, that means this sign. Okay. So that's going to help you write your claim. And then you take whatever sign you have, you flip it, and you either add or remove that equal sign. So that's going to be the first stage of your hypothesis test, is writing the claim and writing the complement of it. Now, what we're going to do is we're going to assign these two statements a role in our test. So both are hypotheses, okay? One is a hypothesis that the claim is stating, and then one is the opposite. And the way we're going to assign names to them is one is going to be called the null hypothesis, and the other one is going to be called the alternative hypothesis. Now, this labeling has nothing to do with what the claim is. So I need you to hear that, okay? We've already established what the claim is. We are going to assign these labels differently. The null hypothesis, we are going to, the notation for it is H sub 0. And the way we say that in Mathland is H naught. Naught is the symbol for that subscript, is the words for the subscript 0. So H naught is going to be the null hypothesis, and HA is going to be the alternative hypothesis. And the way you're going to decide which one's which is the H naught is always going to have the equality. So this will always be the statement that is either less than or equal to, greater than or equal to, or equal to. Those three are going to always be the null hypothesis. The alternatives will not have those. So they'll be strictly less than, strictly greater than, or not equal to. So the first step of your hypothesis will be to write your claim and the opposite. The next will be to label H naught and HA. So let's go back and do that on these claims. So here's our first claim. We're going to look at these two signs. The one that has the equality is going to be H naught, and the other one is going to be HA. Okay. Down here, we've got the first one is going to be H naught, or excuse me, the first one is going to be HA. And the second one's going to be H naught. Why? Because this one has the equal sign in it. That's what makes that H naught. Scroll down. The one with the equal sign is the first one. The second one's going to be HA. So again, it doesn't have anything to do with what the claim is. I always just write the claim first, you know, and then write the opposite. Then I go back and I label which one's H naught and HA. And for purposes of these hypothesis tests, what we're going to do is we're going to assume that H naught is true. Now, we're going to use a technique that we use in logical reasoning for mathematics, and it doesn't really matter which one you assume is true. You're just, for our purposes, we're always going to do it this way. Different books do different things, but the idea is you assume something's true and then you either verify that truth, or you assume something's true and you verify the opposite. Okay, so we're just gonna, for our purposes, always assume that H naught is true, and then we are going to either going to reject H naught, or we're going to fail to reject H naught. Okay. Now this is weird language. Okay, so let's go back to our original example and talk through the language. In our original, we made the claim that the average height is 5 feet 4 inches. So if I was going to write my claim, that I would say that the mean height is 5 feet 4 inches. So the opposite of that claim is going to be that the mean height is not equal to 5 feet 4 inches. So this first one's going to be my H naught. The second one's going to be HA. This first one's H naught because it has the equal sign in it. So we are going to assume that H naught is true. So we're assuming, yes, that that is the mean height of the college students. Okay. Now, if I pull my sample, and let's say, for example, I get my one that I said, I get my average being 6 feet 1 inch. Then I'm going to say, I'm going to calculate this p-value and say, hey, this p-value, which is that probability, is really, really small. Okay, which means that I'm way, way far away from your claim. When p is small, that means that you are in the tail, you are extremely far away from your claim, and that means that we are going to reject H naught. Okay, makes sense, right? Where I'm going to say, hey, you said the average was 5'4". I pulled a sample and I got 6'1". I'm rejecting your claim. Okay. When P is big, we are going to fail to reject H naught. Now, why that language? Let me give you a situation. A person's on trial for a crime, and the jury's responsibility is to listen to all the evidence and decide if he is innocent beyond a reasonable doubt. Okay. Now, if the jury comes back and says, yes, he's innocent, what does that mean? That does not mean that he is innocent. There's lots of people who are guilty. It just means that we don't have enough evidence to convict him. Okay. And that is the language being used here. We are going to fail to reject H naught. Does that mean that H naught is true? Maybe, maybe not, because it might be that we just have a bad sample. We need to run this test again. Okay. But so it doesn't mean that H naught's true. It means that we don't have enough evidence to reject it. Okay. But when I get a sample that is in that tail, then we can actually have concrete evidence to convict or to say, no, that is not a reasonable claim. Okay. So these are going to be your two outcomes depending on what your p-value is. We'll talk about the p-value in the next part of this. Now, if you want to have a strong conclusion to your experiment, this option right here, that outcome is not a strong conclusion. We don't actually have enough evidence to make a strong statement. We want to be able to say this, because when we reject H naught, what that means is that HA is true. Okay, right? If one is wrong, then the other's right. Whereas here we're saying, well, we're not going to reject it, but we're not accepting it either. It's a little wishy-washy. So if you want to support a claim, write HA as your claim. So there's a correct way in writing these to make the outcome make sense and be a strong conclusion for you. If your claim is HA and you get reject H naught, then that means HA is true. So that's the way to construct this. Like if you were actually doing this full-on experiment from the beginning, I would always want to write my claim, the thing that I think is true, as HA. Then I pull my sample, and if I can reject H naught, then that means that my HA is true. And that's the way to get a strong conclusion in this thing. Now, we're going to be doing a lot of different problems. Some of them will have HA as the claim and some won't. That's irrelevant. We're just practicing this process, but I'm just trying to get you to understand the concept of what is happening here and how to make it work for what you want it to do. Okay. I think the last thing that we're going to talk about in this section is what we call the tails of the test. So if you have a situation like we have here, where I make a claim that the mean is exactly one value, I can actually pull a sample that is in the tail on the top or the bottom, right? I've been using this top as an example, like what if I get an extremely high sample at 6'1", but I could also come down here and say, what if I get an extremely low sample at 5 feet even? That's also an extreme and in the tail. And because my claim is an equality right down the middle, either tail is bad. Okay. But not all claims are that way. Some claims, I'm going to scroll down here to this chart. So that's going to be this situation right here. Notice here, it has equality statements. That is what we call a two-tailed test. So either one of those tails is going to be a negative outcome, a reject H naught outcome. The thing that dictates which tail it is, this is a two-tailed test, is your HA value. So if your HA value says not equal, it's a two-tail test. Okay. Now let's scroll up here, kind of going backwards to the chart, but it's a right-tailed test if your HA points to the right. So look at that. Your HA value, the inequality is actually pointing to the side that the tail is on. Okay. So that's going to be that P area that we're looking to either reject or fail to reject. And it's a left-tailed test if your HA points to the left. So the last thing that you're going to do in this section is decide which kind of tail test this is. So if we go back up to our problems and work through those again, our last step would be to say, hey, this is going to be, because HA points to the left, this is going to be a left tail test. And for this claim, because HA points to the left, this is also a left-tailed test. And because HA has a not equal sign, that means this is going to be a two-tailed test. All right, so practically speaking, I mean, concepts aside, what you're going to need to do for your homework is you're going to need to write a claim, write its complement, decide which one's H naught and HA, and then decide what tail test it is. And then we'll run through the remainder of the test next section. There's a decent amount of true and false questions in this section, kind of testing your understanding of the idea. And all of those answers are included in this video. So you should be able to roll through those and find the answers. I will talk to you next time. Good luck.